All right. Hello, good people. Welcome to my mathematics lesson video. Today we are going to focus on a very interesting topic, which is a grade 11 topic. And this topic is sequence and series. Sequence and series. It comes in both in paper 1 and paper 2. That is Zambian curriculum. Okay, paper 1 and paper 2 final examination. Now let us look at lesson number 1, which is, of course, we shall focus on much on arithmetic progression, but start with what sequence is. Now, what is a sequence? So we are simply saying that a sequence is a list of numbers or symbols which follow each other according to a certain rule. Now, what does this mean? We are simply saying that a sequence can be in symbols or can be in numbers. Now, these numbers or symbols, they follow each other according to a certain rule. There should be a rule that makes it to be a sequence. We shall see that in short time. Now, they're also saying that the numbers or symbols in a sequence are known as a term. Keep note of this, they are very important. The numbers or sequence in a term are known as a term. And also they are simply saying that the sequence is a list of numbers that follow. There should be a rule that makes it to be a sequence. If there is no rule, then it means that the sequence of it will not make sense. There should be a rule. Same applies here. There should be a term. These are known as the term. So to be sure that this is a sequence, there should be a rule that indeed helps us to find each term that makes the first term there should be a rule that makes us to find the next term. There should be another rule that makes us to find the third term, just like that. And they are simply telling us that the numbers or symbols in a sequence are known as terms. Keep note, don't forget this. So now, examples of sequences, we have 8. Now, Roman numeral 1, we have 8, 15, 22, 29, 36. Another one, we have 4,444. Now, when you look at this sequences that we have been given here, to apply this concept which is on top here, we need to find the rule that will make this number 1 to be a sequence. So how do I find the rule? The rule is simply found by, look at this sequence. From here, this is 8. What do I have to add next in order for me to get 15? That is another way you can look at this one. You see, you are increasing, you are not decreasing. So when you are increasing, simply means that I need to add a certain number that will make me get 15, 22, 29, and that number should be a constant. So what number is that? Now let's look at this the way they are simply saying Roman numeral number 1. All these which are here, it is what they are saying that Roman numeral 1, we have sequences which we need to call term. Now term, we can abbreviate it in this manner, or we can abbreviate it in this manner. There is term and A. This simply you can represent terms. So now let us look at term 1. What is my term 1 in a sequence Roman numeral 1? Term 1 is 8. So meaning that 8 will be my term 1. What is my, so you can simply also say, what is my A, which A1, which is term 1, which is same as 8. What about my term 2? What is my term 4? Term 4 in this sequence, it is 1, 2, 3, 4, 29. It is 29. Or you can say A4 is equal to 29, like that. So that is how we write terms in a sequence. So this is how we write terms. But what about the rule? What is my rule in this sequence? The rule simply means that I need to add a certain number for me to get 15, 22, 29, and 36. What number is that? So for me to easily find the rule, I'm going to say what is 15 minus 8? So we're going to say 15 minus 8, I'm going to get what? 7. So meaning that my rule in this scenario, it will be 7. So I need to add 7 to get the next what? Term. That is my rule for this one. So how true is this one? Let's try with 15 plus 7. What do I get? 15, 16, 17, 18, 19, 20, 21, 22. I get, is it 22? Yes. Term 3, so it will be 22. So what is my term 3? Term 3 is 22. You see that? So this add 7, it is simply the rule that is going to apply here. So when I add 7 in each term here, I'm going to get the following term. Same applies when I say what is 29 plus 7, I'm going to get 36. So that is how we can write the terms, and this is a rule that makes it to be true. Add 7 to get the next term, which is 15 plus 7, 22. Or if you want, you can try it by simply saying, let us not add 15, let us add maybe, let's say, what is 29 plus 7. What do I get? 29, 29, 30, 31, 32, 33, 34, 35, 36. We get 36. So what is my term 4? So this is term what? 1, 2, 3, 4, 5. So we are going to say what is my term 5 is equal to 36. So the rule, it is true. Hence this one qualifies to be a sequence. That is how you prove, that is how you know that this is a sequence. What about this one? As you can see, this one we have 4,440 to 4. So there is a rule that makes these numbers decrease. They are decreasing in this scenario. So you cannot say I subtract in this manner, but in other ways you can look at this 4,000 to 400, from 400 to 40, from 40 to 4. What is happening here? The numbers, the sequences are decreasing. So they are decreasing by, in a sense, well, let me see. When I divide this sequence by 10, what do I get? This cancels and we have 400. I have 400. When I divide this by 10, I have 40. When I divide this by 10, I have 4. So this simply means that, okay, this simply means that if I divide, okay, now the rule number 2 of Roman numeral 2, rule is simply divide the terms by 10 to get the next what? To get the next term. That is a rule, to get the next term. So in order for me to find, let me prove this one by simply saying that, let me find term 1, 2, 3. Term 3. What is term 3? We are simply saying that for me to get term 3, I need to divide 400. So I'm going to say 400 divided by 10. What is my term 3? It will be 40. Is this true? Term 3, is it 40? Yes. Term 3 is equal to 40, which is this one. This is term 1, term 2, term 3, and term 4. So term 3 is equal to 40, and hence I've proved here, hence you get the answer correct. So that is another way you can find this proof that these are true sequences. Okay, hopefully I've made this sequence easy for you. Now let's come and look at types of sequences. Now, types of sequences, here we are going to focus mostly on arithmetic progression and geometric progression. This arithmetic progression, sometimes it may be called AP, and geometric progression, this one also can be abbreviated as GP. So instead of saying geometric progression, you can just say GP, or instead of saying arithmetic progression, you can just say AP. So let us now focus on what we call arithmetic progression. Arithmetic progression, we can call it as the AP, arithmetic progression. Okay, so let me just erase this part. Hopefully you have understood the part, so we make this part clear. Okay, arithmetic progression. Now, what is arithmetic progression? An arithmetic progression, AP, is a sequence. Okay, it is a sequence of numbers such that the difference between any two consecutive numbers is a constant value called the common difference. So we are simply saying that arithmetic progression is simply a sequence, in a sense that that sequence should have any two consecutive numbers, like for example 8 and 15. The difference between these two should be a constant. Now that constant value, it is what we call the common what? It is what we call the common difference. That constant value, it is called the common difference. So the number in between this, the rule, that rule, it is called the common difference. In other words, we can say, what was the rule between these two? The rule between these two, it is the add 7. So 7, in other way, it is what they call the common difference in arithmetic progression. Okay, so now each term is found by adding. So for me to be able to find the next term, I need to use the common difference and add it to the first term to get the second term. So if I want to get the third term, I need to add the second term plus the common difference to get the third term. That is what they mean by simply to get each term find by adding constant value or common difference. And common difference sometimes can be represented by letter D. Just D, it represents common difference. Okay. Now, what is the rule or the formula for me to use to find the common difference in arithmetic progression? The formula, it is simply, the common difference is given by D is equal to T2 minus T1. Now, this T2 simply stands for term 2 minus term 1. Let me just write it here. So we can say common difference D is equal to term, okay, term 2 minus term what? Minus term 1. In order for me to find the next term. So that is how we find the common difference. Or you can simply say term 3 minus term 2 or term 4 minus term 3. Just like that. If you do it like that, you're going to be able to find the common difference without any problems. Okay, so master this concept. It's very important to master it so that you don't forget how to apply this concept. This is somehow, you can say, the rule that you, or the method that you use to find the common difference. Now, example. The following sequences are arithmetic progression, AP. Now, find the common difference. That is what we... So we're going to find the common difference by using these formulas which are there. So I would advise you to pause the video at this moment and then try to answer this question by using this method and see if you can get it the correct answer before we do it together. Pause the video now. Solutions. Okay, so now let's see if you found the correct answer. So for me to find the common difference, let's start with question number 1. Sequences, we are given sequences 2, 6, 10. Now they want us to find the common difference for this sequence which is here. Once we see something going like this, simply means that this sequence, it is infinite, it does not end, it continues going. Okay? So let us look at this scenario. We're going to say, for me to find this one, I need to identify first. What term is this one? This is my term 1, and this is my term 2, and this is my term 3. So I'm given 3 terms in this sequence. So it simply means that for me to find the common difference, or I can simply say, let me write common difference, which is represented by D. For this scenario, it will simply is going to be T2 minus T1. T2 minus T1. What is my answer now? What is my T2? It is 6. Minus T1, it is 2. So therefore, what is 6 minus 2? We have 4. So 4, therefore, D is equal to 4. What is my common difference for this one? It is 4. How true is this? When I add 2 plus 4, what do I get? 6. 6 plus 4, what do I get? 10. So meaning this 4, it is my rule. I'm adding. Hence, I'm done with this one. Now let us go to the next one, B. So I have the sequence which is 1, 5, 9, 13, 17, 21, and this goes on and forth. So for me to find the common difference, I'm going to say D is equal to, I can use any term I want here. Let me say T4 minus T3. Remember when I said T4, term 4, I need to subtract term 3 from term 4. So it's simply going to be, what is going to be? What is my term 4? Term 4, it is 1, 2, 3, 4, 13. Minus term 3, it is 9. So what is my final answer? So we're going to, you don't use your fingers, that's why God gave you. So to subtract, you can use your fingers so that you can appreciate the gift that God has given you in mathematics as well. So we have 13, 9, 10, 11, 12, 13. So it is what? 4. So also here we have our answer to be 4. Therefore, the common difference is equal to 4. That is true. Let us prove now. Let us prove this is true. Let's say proof. We are going to add the first term to the second, to the common difference, and see if we are finding the next thing, the next term. Let's say we have 9 plus 4. What is 9 plus 4? 9, 10, 11, 12, 13. We have 13. So 13, it is my term 3. Term 3 is equal to 13. Is this true? 1, 2, 3, 4. No, it is term 4. So for me to find term 4, I need to add 9 plus 4 to get term 4. Now, how do I find term 3? Term 3, I need to add, this is term 3. So I need to add term 2. So it will be term 2 plus the D to find the term 3. So this one, it will, what is my term 2? 1, 2, 5 plus, what is my D 4? So what is my term 3? It will be 5 plus 4, it is 9. Let us prove. 1, 2, 3, correct. Term 3, it is simply 9. Hence, the rule, the common difference, it is telling us now, this is the common difference you have found. When we add the common difference to the previous term, we are getting the next term. So that is how you find the common difference, dear ones. Now, same applies with this one. How do I find the common difference for this one? I need to just simply say, for common difference for this one, let's come to C. We are going to do the same procedure. 9 over 2 minus 4. So what is the answer? Let's see how you can do it yourselves. Okay, so now let's see together. We are going to say common difference for this one. It is, we are going to say term 2 minus term 1. Okay, term 2 minus term 1. So what is my term 2? My term 2, it is 9 over 2 minus 4. So for me to be able to subtract this one, I need to make the 4 a fraction. So that when I make it a fraction, it will be 9 over 2 minus 4 over 1. Common difference here. What is the what is the denominator? I mean not common difference, but what will be the denominator for these two? The number that is common on both sides, that is what I do. Or you can simply say, what is 2 times 1, which is the common denominator, which is the 2. So the common denominator will be 2. So 2 into 2, it is 1. 1 times 1, 9, it is the 9, minus. 1 into 2 is 2. 2 times 4, it is 8. Okay? So we are simply saying, what is 9? Okay, let's continue, move it from here. 9 minus 8. What is 9 minus 8? Is 1 over 2. So my common difference is 1 over 2, or you can simply say 0.5. But I would advise you not to use this one, but to use this one, a fraction, because this is paper 1. Decimals, they are sometimes challenging to work with. So the common difference for this one, D, it is equal to 1 over 2. Okay, if you find 0.5, I'll still mark you correct. So that is the common difference for C. That is how you find the common difference, dear ones. Hopefully I've made this so simple for you. I expect you to be able to answer these questions without any challenge. So the next thing now it will be, we are going to concentrate on finding the nth term. So let us see how we can find the nth term. Nth term. So when I say nth term, I simply means nth term. So that is the next thing. Let us see how we can find the nth term. Now that we know to find the common difference, the nth term should also be simple for us to find. Okay?